Hi boys and girls, today we did Unit 6, Lesson 18, Subtraction and Equivalent Expressions. So for each expression we're going to write an equivalent expression that uses only addition. So wherever I see subtraction, I'm going to change that to addition. So here I'm going to have 20 plus, when I do that, this number is going to become its opposite, negative 9 plus 8 plus a negative 7. Okay, this one I have 4x, change that to addition, do this opposite, so that would be a negative 7y, change this to addition, do this opposite, so that would be a negative 5z plus 6. Okay, this last one here we have negative 3x plus, change that to its opposite, negative 8y plus negative 4 plus negative 8/7 z. Okay, and that's all you had to do on that one. To use the distributive property to write an expression that is equivalent to each expression. If you get stuck, consider drawing boxes to help you organize your work. So we've talked about just multiplying throughout. So 9 times 4x would be 27x. Oh, I'm sorry. What am I talking about? Not 27. 36x. And then minus 9 times 3, there's 27, and that would be y. Minus, I'm taking 9 times 2, which is 18, divided by 3, which is 6, so minus 6. Okay, this one again, using the distributive property. Negative 2 times negative 6, that's going to give me a positive 12, and then x, plus a negative 2 times 3y, be negative 6y, and then minus a negative 2 times a positive 1, be negative 1, be negative 1. I mean negative 2, excuse me. Ooh, that's kleuthy. Pay attention today. Since I have this double negative here, what I could actually do is make that 12x plus negative 6y and just plus a positive 2 since I have that double negative. So either one would work. Okay, C. Multiplying a fifth times each of these numbers. A fifth times 20y, so basically I'm taking 20 divided by 5, which is 4. So I have 4y minus a fifth times 4x, that would give me 4/5 x minus, and a fifth times 13, that would give me 13/5. Okay, this one, 8 times negative x would give me negative 8x minus 8 times a half. Half of 8 is 4, so negative 8x minus 4. And for E, again, multiplying throughout here, negative 8 times negative x would give me a positive 8x minus negative 8 times 3/4. So I'm taking 8 times 3, which is 24, and then I'm dividing by 4, which is 6. So that'd be a minus a negative 6y plus, we're going to have a negative here, negative, so I'm taking 8 times 7, which is 56, and divided by 2, which is 28. Now again, I have this double negative, so I actually could rewrite this as 8x plus 6y plus that negative 28. So either one would work. Okay, 3. Karen wrote the expression x minus 10 for this number puzzle. Pick a number, add negative 2, and multiply it by 5. Lynn thinks Karen made a mistake. How can she convince Karen that he made a mistake? So he has x minus 10. It says to pick a number, add -2, and multiply by 5. So if I pick a number, let's say I pick 12, and 12 minus 10 would give me 2. But this one says pick a number, 12, add -2, and then times by 5. And because the way this is worded, I have to do this part first before I can multiply by 5. So I'm taking 12 plus -2, which is 10, sorry, -10, and I'm timesing, whoops, what am I talking about? Nope, positive 10, times 5, so that would give me 50. So do these match? No, so she can convince them that way. What would be the correct expression for this number puzzle? So correct expression would be that number x plus -2, and then we're multiplying that by 5. I could even use the distributive property and have 5x plus a -10, which would be the same thing. Okay, the output from a coal power plant is shown in the table. Okay, similarly, the output from a solar power plant is shown in this table. Based on the tables is the energy output in proportion to the number of days for either plant. So we need to find our constant for each one of these. So we can take our y divided by x. So when I divide these two numbers here, I get 0.002. Okay, let's take 3.6 divided by 1800, 0.002, 8 divided by 4000, 0.002, 20 divided by 10,000, 0.002. So this one, they're proportional. Okay, let's check this one here. Okay, sorry about that. So let's go ahead and check this one. So we're taking 1 divided by 100, which is 0.01. 4 divided by 650. Whoa, that doesn't look good. I'm only going to go that far. 7 divided by 1,200. Okay, already I can probably tell this is not going to be proportional. 10 divided by 1750. 0.00571. Okay, so those did not match. So based on the tables, it's the energy output in proportion to the number of days for either plant. The coal power plant? The coal power plant is proportional. The solar power plant is not proportional. If so, write an equation showing the relationship. If not, explain your reasoning. Right here, these are my reasonings for these. Okay. Write an equation. So my equation for this one here would be y equals my constant times x. Okay, now if I had divided the other way, I would have gotten 500 each time. Okay, and that's going the other way, so I could also have the equation of my energy equals 500 times the number of days. Either one of these would be the constant and it would work. Okay, please let me know if you have questions.